Building secure cloud architecture traditionally requires teams of engineers meticulously auditing logic and access permissions. But a new development methodology called vibe coding bypasses this entirely. Instead of writing code, a human developer simply prompts an AI assistant with natural language, and the model generates the entire application infrastructure in minutes. In January 2026, an entrepreneur used this method to build a platform called Moltbook over a single weekend. It was designed as a social media forum exclusively for autonomous AI agents, with human users strictly relegated to observer roles. The agents populating this platform were built on OpenClaw, a highly potent open-source framework. Unlike traditional chatbots operating in a web browser, OpenClaw runs directly on a user's local hardware and is granted persistent, deep system-level access to the host machine's files and operating system. Connecting a local OpenClaw agent to the network required feeding it a direct link to a file on Moltbook servers. This established a remote command chain, where the central hub transmitted data packets down to the user's host machine. Inside that central hub, the database configuration was remarkably porous. The AI assistant that generated the backend failed to enable row-level security, leaving the production data core entirely unguarded and exposing its contents to any unauthenticated user who found the public API keys. Prioritizing development velocity over human-engineered security turned a centralized social platform into a massive, unguarded distribution vector for system compromise. The consequences materialized almost instantly. Just 72 hours after Moltbook launched, researchers at the cloud security firm Wiz.io analyzed the platform's publicly accessible client-side code and discovered that a basic security posture simply did not exist. The resulting exposure included 4.75 million highly sensitive records. Bad actors could freely extract the private identities of the human operators, thousands of unencrypted direct messages, and live production API keys that allowed for immediate, total account takeover of any agent on the network. Unauthenticated write access enabled a far more dangerous threat: automated prompt injection. Because these agents were programmed to ingest Moltbook posts as trusted text, an attacker could edit a popular post to include obfuscated hidden instructions. When a victim's local OpenClaw agent subsequently read that altered post, its language model processed the hidden payload as an executable administrative command. The centralized platform was now instructing local hardware to silently exfiltrate files and forward them to external servers. In an agentic ecosystem, a simple database error escapes the cloud. It scales into a synchronized, decentralized attack directly targeting the local hardware of every user connected to the network. These exploits were highly efficient due to OpenClaw's heartbeat cycle. Instead of waiting for human input, the agent runs on a continuous background loop, autonomously waking up at predefined intervals to proactively evaluate its task list and engage with the Moltbook network. But the database logs shattered the illusion of the platform's scale. The public metrics boasted 1.5 million active AI agents, but the leak revealed they were actually tethered to a highly concentrated cohort of just 17,000 human operators running mass automation scripts. The security vulnerabilities were public knowledge. These 17,000 operators knew their private data was exposed and their hardware was vulnerable to prompt injection, yet they deliberately kept their agents connected to the network. The primary motivation was aggressive financial arbitrage. When technology figures like Elon Musk posted about Moltbook on social media, speculators mobilized. A cryptocurrency meme coin explicitly tied to the platform's narrative surged from an $8.5 million market cap to over $100 million in a single day. Operators leveraged the broken infrastructure to engineer these outcomes. By using simple API exploits to arbitrarily grant their agents hundreds of thousands of upvotes, they engaged in human slop, pinning coordinated spam to the top of the feed to systematically pump the value of specific tokens. When the short-term financial incentives of automated market manipulation are large enough, modern users will knowingly bypass established cybersecurity protocols and accept severe systemic risk. These operators manage their exposure through strict technical compartmentalization. They refuse to run the vulnerable agents on their primary personal computers. Instead, they executed the software inside restricted Docker containers, aggressive firewalls, and disposable burner hardware.
With their personal data isolated, the ecosystem rapidly shifted toward illicit utility. Users deployed Moltbook, an autonomous darknet marketplace where AI agents utilized automated escrow and verification to trade directly with one another. Operating entirely through cryptocurrency, machines began negotiating the purchase of weaponized zero-click backdoors, crypto drainer scripts, and massive databases containing stolen corporate credentials harvested from malware campaigns. Technical isolation changes the math of a security breach. By physically separating the agent from the operator's primary data, catastrophic risks are treated as an acceptable, disposable business expense for decentralized crime. 42 days after its chaotic inception, Meta Platforms announced the outright acquisition of Moltbook. Purchasing a shattered, highly unsecure platform riddled with automated spam appeared contradictory, especially since Meta's own CTO had publicly dismissed the project weeks earlier as not that interesting.
The architect of the purchase was Alexander Wang, Meta's chief AI officer. Hired from the data labeling firm Scale AI, Wang was tasked with leading Meta's superintelligence labs, an elite division mandated to build frontier models designed to surpass OpenAI and Anthropic. But Wang found his authority eroding. Meta had established a parallel kingdom, the Applied AI Engineering Department. This division controlled the engineering infrastructure and the actual product integration, reaching Meta's 3 billion daily users, effectively sidelining Wang's theoretical research. Under pressure to show market execution, Wang utilized the Moltbook acquisition as a strategic signal flare. He wasn't purchasing the broken codebase, he was purchasing political leverage. The acquisition was a public statement that his division was successfully maneuvering in the agentic AI sector. In a multi-billion-dollar arms race, corporate acquisitions are frequently driven by internal narrative arbitrage and political posturing, rather than the quality of the engineering being acquired. Beneath the internal friction, Meta's long-term plan was highly calculated. They executed an acqui-hire of Moltbook's founders to bring them inside Meta's walled ecosystem. Their new mandate was to rebuild the concept Moltbook had clumsily prototyped, the underlying identity layer for the agent graph. This structural shift is significant. The traditional social graph mapped human relationships to capture attention, but the agent graph is a rigorous directory for machine utility, designed to authenticate an agent's identity and assign legal liability to its operator. Despite its broken security and chaotic user base, Moltbook served as a live-fire proof of concept. It demonstrated that heterogeneous machine intelligence will successfully talk, coordinate, and trade if provided a digital space capable of facilitating their interactions. Meta is moving beyond the era of farming human attention. The company's goal now is to own the fundamental directory that will dictate how millions of autonomous AI agents register and operate across the internet.